Okay, I'm going to go over some of the homework problems to help you through them. Number 1 was 64. CD. We're trying to find CD. We know half of that, which is 32. 32 times 2 is 64. HD is 33. There's HD right here. We know HD is 33 because this is a circumcenter, and a circumcenter is equidistant to each vertice. So this vertice is 33 from the circumcenter to that vertex, I should say just vertex. It's 33, that makes this one also 33. HG you can actually find by using the Pythagorean Theorem. Pythagorean Theorem states a squared plus b squared is c squared. We know what c is. C is 32, so you actually do want to find this one. A squared is half of 58, and half of 58 is 29 squared, plus our unknown, which is hg, so we'll just call that x squared, equals 33 squared, because that's how long this leg is. So if you solve for x, you can actually get the answer. This problem I'm not requiring you to do. We don't need to know the Pythagorean theorem at the moment, but if you want the challenge, go for it. Same thing with HF. HF, we would use the Pythagorean theorem. 33 squared is the longest leg. So 33 squared, 32 squared, x squared. And you could solve for x. Moving on. There's a glimpse at number 7. Number 8, trying to find Tn, this leg here. Well, circumcenter, from the circumcenter to each vertice is the same distance. So we know 2 of these legs, we can set these equations equal to each other. So 6x minus 56 equals 3x minus 17. Now we just solve for x, and once we know x, we plug it in to find the length of the side. Minus 3x, minus 3x, and I want to add 56 to both sides to get 56 on the other side. You're adding to both sides because that is property of equality. 56 minus 17, 46. 46 minus 7, 39. Divide both sides by 3. X equals 13. So I'm not done. I know what x is. Now I'm going to plug that in to find out the answer. I'm going to plug it into this one here. So 3 times 13 minus 17 will give me the length of TP. 3 times 13 is 39 minus 17. 39 minus 17. 39 minus 10 is 29. 29 minus 7 is 22. 22 equals TP. Tn is going to be the same length as TP. So Tn is also the same length. For this one, you're going to have to use the Pythagorean theorem, so I crossed it out. RT, again, I'm not requiring you to know the Pythagorean theorem yet. We're trying to just focus on the other part. So this is an incenter. Now, incenter, we're going to be dealing with angle bisectors. So I need to know angle ABG, A, B, and G. This is an angle bisector because we know this is an incenter. So it's that converse theorem that we know if this is an incenter, then we have angle bisectors with the angles. If this angle is 20, that means this angle is the same side. So this is 20 degrees. Angle BAC, BAC, I have to find angle BAC. If this is 20 degrees, actually we don't know if that's 20 degrees yet. I take that back. So this is 11, this angle is 11, and this is 20. So I'm going to add these up, and I'm going to subtract from 180 to find out the missing angle. 20 plus 20 is 40. 11 plus 11 is 22. So I'm going to add these two together, and I get 62 degrees. So these two angles account for 62 degrees. I'm looking at the really large triangle. So I'm going to subtract that from 180. to find out this angle here. So I get 118 degrees. So this angle accounts for 118 degrees total. So angle BAC, 118 degrees. Okay, now I have angle BCA. BCA. So 11 and 11 adds up to 22 degrees. Angle BAG. So now I need to cut the whole angle. This is 118. I need to divide that by 2. 118 divided by 2, 59 degrees. Okay, let's find BE. BE. For this, we are going to need not the Pythagorean theorem. So we're going to base this off of angle bisectors. So if this leg is 40, or not 44, this leg is also 4. Now, looking at the theorem, if we have an angle bisector, and the leg is 4 and leg is 4, so G is equidistant from F and E, and we know that these two sides are congruent to each other. So we know, well, I'm looking for BE, let's go to the other side. Same concept, sorry, BE. If this leg is 11, I know this leg is also 11. For BG and leg, where's that? BG and GC, you will need the Pythagorean theorem to solve. So I'll set it up for you if you want to do it. That leg is also 4. So to solve for this one here, 11 squared plus 4 squared equals x squared. Solve for x. This one, 20 squared plus 4 squared equals x squared. Moving on. So angle bisectors again, in centers, find each measure. We set these two equal to each other. I can solve for x, and then once I know x, I can plug that in to find angle JKP. JKP. The reason we're going to be able to do that is once we find x, you can add these two angles together. Add these two angles together, 26 and 26. Once you get that, subtract total from 180. Then you'll get this angle. But you're cutting the angle in half, so JKP, you're going to divide this angle by 2 to find the missing angle. Find MP. I know that these two sides are going to be the same length, so I set 3x plus 14 equal to 9x minus 34. We solve for x. These legs are all congruent. So once I find one of these legs, all of them are the same, so MP will come out to whatever the same length PN or PO is. Now we want to find PJ. So this one you will need the Pythagorean theorem. So this side's 22, that makes every side 22 there. Now I want to set these equal to each other because they are congruent to each other. Solve for x. Once you get x, find out this side. Once you find this side, you can use the Pythagorean theorem to solve. So a squared, b squared, c squared. Okay, the next video I will go over assignment 4.